So in this particular lesson, we are going to discuss how a typical production-like certificate authority and certificate manager looks. We are going to look at ACM, AWS Certificate Manager, and AWS Private CA. They are two different services provided by Amazon. So this demo costs a little bit of money if you're using AWS. Be aware about that, especially the Private CA if you're planning to create. It costs a lot of money, like hundreds of dollars if you keep it running. But this is how things are done in production in real world, in a company environment, in a corporate environment. This is how it is done, all the certificate management with a private certificate authority. In the end, we'll touch upon code signing and a couple of other topics, which is related to digital signatures and things like that. Now, let's get into the topics. So AWS, ACM, and Private CA. So this is a production level implementation or a sample production level implementation or one of the production level implementation of a proper CA, a certificate authority, and certificate management system. A lot of the organization has internal certificate management system like financial institutions and things like that. To get a feel of that, we are going to discuss ACM and PCA, the actual AWS offerings, managed service which manages certificates. Nothing fancy, nothing new. Everything we have discussed, it's just that AWS is providing everything with a little bit of extra bells and whistles and extra bit of security. All the keys will be saved in some kind of hardware key management system like HSM. Don't worry if you're not familiar with it. But at the end of the day, AWS or most of the cloud providers give a way to save certificates, mostly to use with their own services, especially ACM. ACM doesn't work for public certificates for things like Nginx and things like that, because you can't export public certificates from ACM as of now. Not sure why they have designed it like that, but that's what it is as of now. But you can export private CA certificates from ACM. We'll see all these different possibilities. So what is ACM? So ACM does a couple of things. One is create certificate, create certs, which has two variants. One is public and private. To create a private certificate, you need to have a private CA, which means you have to pay more money to AWS. Private CA. This is another service altogether, cost around $500 a month, even to create it. And public certificate you can create just like the one we are having from google.com or facebook.com or any website or application you get. It's a public certificate and the CA will be trusted by all the browsers and operating system. So it's a normal public certificate, and this certificate you cannot export, which means you can't get the private key and put it into something like Nginx. Then what is the use of it? It can be used for ALB, the Amazon load balancer, then something like CloudFriend, then a couple of other AWS specific services, which are nothing but load balancers on steroids, like API gateway and things like that. Basically, they're on Nginx. So that is a short explanation about the certificate creation. Then, of course, you can renew the certificate. There is no CSR business. I don't think the public certificate creation is done using CSR. You just pass the names, we'll see shortly. So it is pretty straightforward that way. Renew certificate. Another thing it does is keeping the key secure. Key security, which means you never access the key of a public certificate. For private certificates, it is slightly different scenario, but public certificate, the key is never exported. Very important point to consider. So key security, and of course you can perform all the deletion and management, typical management of certificate. Now for generating all the public certificate, you need the verification and things like that. That's what we are going to do. We are going to create a public certificate. We will not create a private CA. We have already done that. We'll have a look at this private CA console. We'll just theoretically discuss about it. But if you want, you can create it, but it'll cost you a lot of money, like $500+. So be aware about creating private CAs. But ultimately, it is the same thing we have done using OpenSSL. You're not going to learn anything new about it. Now, if you create a private CA, you need to connect it to the certificate manager to export the certificate and things like that. We'll discuss about it. Now, what we can do is we can go to the AWS console and see some of these things. Before we get into the console, I'd like to look at the documentation of these things to show you how to understand different features provided by these services, these managed services. So these are the command line or the CLI reference of ACM, Certificate Manager. So this gives us a good picture of what it does. Whenever there is a new service from AWS, this is what I do. I just go to the CLI and look at these commands. This is pretty self-explanatory. Add tags to certificate. This is given in the alphabetical order. Delete, describe, export, get account configuration. It's all pretty much self-explanatory. So there is something in the end called wait. Wait for what? So this is like an automation command. Don't worry about it. It has nothing to do with certificate. You will see with pretty much all the CLI. This is to wait for something to complete. So that is the wait, except that pretty much everything else is self-explanatory. So what I recommend is that if you have any kind of questions or thoughts about this kind of services, just go to the CLI and look at what it provides. Renew, request, recent validation, all that kind of things. Validation part we are going to see shortly. So this is the get certificate documentation if you want to have a look. So you can read about it. Normally there is not a lot of explanation, but from the arguments it is taking, the certificate ARN is nothing but the name of the certificate. It is not the C name, but it's just the unique name AWS is giving for its objects, the ARN, Amazon Resource Name. So every object has a name. So everywhere where the certificate is getting used, we will be using the ARN instead of anything else. So request certificate. So this is the request certificate API or the CLI command. So request certificate, as you can see, it takes a domain name. It is not taking an ARN. In fact, it gives you an ARN. So domain name is nothing but C name. So as you can see, Amazon is using the word domain name instead of C name or subject alternating names or anything like that. Also, it is in the documentation, if you look, it is using FQDN. If you look here, so let me annotate that for you. So if you look here, we are talking about FQDN. What is FQDN? Fully qualified domain name. What is that to do with here? That is exactly our C name or CN. And this is a SAN. As I mentioned before, these names are slightly used differently in different places. So this is a more correct term from the modern perspective, FQDN. But in certificate, you will see it is used as C name. So when you read the documentation like this, don't get confused. The jargons are little different in different places. So be aware about that and stick to your fundamentals. All the fundamentals we learned so far, that cannot be changed. RSA cannot be changed. DH cannot be changed. Signing cannot be changed. But this kind of jargons can be changed and used in different places to confuse people. So this is the request certificate API. Now, if you look at another one, renew certificate. Again, similar kind of documentation. You can pretty much see the same manner. We are taking the certificate ARN. Now, let's have a look at the private CA documentation. Private CA documentation. Again, we are going to the commands of the private CA. There are two different services. They are related, but two different services from Amazon. So this is ACM PCA, ACM-PCA, private CA. They are connected, but not same. They have different set of CLI commands. Even they have some overlaps between them. For example, something like get certificate. As you can see here, get certificate is there in both PCA and ACM. But there are things like export certificate is missing. If you want to export a certificate, you need to connect the ACM to a private CA. So all that kind of things is needed. All of this kind of different, slightly different versions of the API. Again, this is all very Amazon specific. This is not a general concept. Like you have to manage certificate in some place and you need to have private CA in a different place. This is how Amazon has designed it. For a different cloud provider, could be different. or they can have a single service called Certificate Manager and it has all these functionalities you're looking for. But Amazon has made it two different services. Again, if you want, you can look into the details. Import certificate authority certificate. This is like you can import your own certificate authority and you can import your own certificates into the system with the private key, and you can manage within AWS. Basically to provide a way to import your custom on-prem CA into Amazon. That is what this particular API is all about. So one of the things with this private CA is that it is very expensive. If you're doing the demo by yourself, make sure that you don't waste a lot of money. Read the cost details. It can cost up to $500 when you use it. Now, what we are going to do is we are going to get into the console of the AWS and we are going to look at some of these services. First, what we are going to do is we are going to create a certificate in ACM. We are going to create a public certificate because it doesn't cost too much money. So I'm going to go to Certificate Manager and later to the private certificate authority. So first we are going to Certificate Manager, and what I'm going to do is I'm going to click on request a certificate. So this is a proper production certificate we are going to generate. So there will be validation step. That is what I wanted to tell you about and show you how is the validation done when you generate a public certificate. The private certificate doesn't need validation because it's a private domain. It is not trusted by any browsers. So in our case, we are going to request a certificate. As you can see, we don't have a private CA. That's why the request a private certificate is turned off. Request public certificate, that's what we are going to do because we don't have a private CA. But you can create a private CA if you want using the private CA we have seen before. So request public certificate in this case, clicking next. And DNS validation is what we are going to do. Basically, it'll ask you to prove that you own the DNS of XYZ domain you have created. So very important. This is the main part of the validation. That's why even we are looking at this particular lesson, how the validation works. They are asking us to put a custom value, a random number inside your DNS. Only if you own the DNS, you can do that. If you don't own your DNS, you cannot put a random value into the DNS entry. For example, you can't do a CNAME to google.com because you don't own that particular domain, or facebook.com, or any custom domain like that, custom public domain. You cannot put random entries. That is exactly what they are asking us to do. Put a custom, if you own this domain, put a custom value into the DNS record. So let's get through it. So the key algorithm is here. Before that, we need to go to the fully qualified domain name. We are going to give dev.sourcesense.com.au. The reason is we own this particular DNS. So we'll be able to change the DNS such that the criteria for this particular certificate generation can be met by changing the DNS records. We can add another name as well, sourcesense.com.au. We own this particular domain as well in GoDaddy. That's where we manage the DNS. Again, back to the key algorithm. One of the things to notice here is the ECDSA P256. So this is something we have discussed before. Let me annotate now that I'm seeing it in the screen. So this is the RSA 2048, the normal one, we have used it. This is ECDSA P256, equivalent in cryptographic strength to RSA this much, which means that there is a key compression we have done using elliptic curve, EC, elliptic curve digital signature algorithm. So there's a key compression, 256. The length is very small, but it's equivalent to very high value. Same with this one, more than 20 times powerful, almost 20 times powerful than this much key length. So that is the elliptic curve cryptography. Shorter keys has more power, like we discussed before. Just I saw that, that's why I wanted to highlight that particular piece of information. When you see this kind of things, it should make sense to you. That's the whole point of this training. So when you read this kind of cryptic messages, you should know what it means. So let's get back to what we were discussing. We were generating certificate and we saw this thing and we kind of little diverted. And DNS validation, and we have given all this fully qualified domain name. So one of those things will be SNI or SAN of the certificate. while the other one will be the CNAME. So I'm going to add a tag, so test tag. This tag won't be coming in certificate, it's just an AWS thingy. It has nothing to do with the certificate. I clicked on request certificate. Now the certificate is in pending validation stage. As you can see right here, it is in pending validation. So you can look at the details of these things. What is it pending on validation? It is pending on validation of the DNS records. Then only it'll be in issued state. So this is the ARN of the certificate, just a huge string which is unique to this account as well as the certificate. For every object in AWS has an ARN, resource name or a resource identifier. So have a look at this page if you're doing this demo by yourself, and these are the DNS records. We need to create the CNAME. So we need to create the CNAME and corresponding value inside our DNS to make sure that this works. Once you have given that CNAME and that value within your DNS, your certificate will start working and it will be moved to a issued status. Right now it is pending validation. This is a common process with all kind of CAs, not just AWS. They will ask you to do something to your DNS and you have to create the DNS entry before you make the validation correct. Then only the CA will give you the certificate, proving that you're owning the domain. So these are some of the other details on the certificate, all the RSA key and things like that. As you can see, issued at not applicable, not before, not after, all those things are not applicable. So domain name is this particular string right here. It's more or less like a certificate request. Can be used with, this is one more thing we would like to focus, CloudFront, Elastic Load Balancing, API Gateway, and some other services. Which means that this certificate which we are creating cannot be exported and used for random purpose like an Nginx or an Istio or Envoy or something like that. You cannot export the private key or this particular certificate which you are going to create. Very important. And because of that reason, I don't think it costs much as well. I don't know the cost of this, but it should be very less because you can't export the private key of this particular certificate. So the next main thing to do here is to make those DNS entries which they're asking to issue the certificate to prove that we own these domains, these public domains, dev.sourcesense.com.au as well as sourcesense.com.au. Because Amazon is going to provide a certificate saying that we are the owners. So we need to prove that to Amazon before it issues the certificate. That's the main thing we need to do. And what we're going to do is that we are going to go to the DNS of this particular domain, which we have control on because we own that domain, which is right now we're going to do it in GoDaddy. Basically what we are going to do is that we are going to add these CNAMEs right here. If you are new to what is a CNAME or a DNS record, feel free to watch the previous trainings on networking. We have a lot of details in that training, what it is. But at the end of the day, what we are going to do is that we are going to make two entries inside the DNS. Both are CNAME records. So this is the DNS console of GoDaddy. So I'm going to click on DNS for sourcesense.com.au and we are going to add a record. So we are going to add a CNAME record and the details of that record is given by the Amazon. There are so many other records right here. So we'll be getting the data from Amazon. It is there in the previous page what to add here. Fairly straightforward process if you own the domain. So I'm going to get these values copied, CNAME and CNAME value. Those are the things we need. These are all random numbers. I have copied it and I'm going to add a type CNAME. There are so many other types and going to paste it, going to copy the value and paste the value as well. Half an hour TTL is fine. TTL is time to leave. We have no TTL definition, but normally 30 minutes is good. I have saved that record. Let's create the other record for the other domain. One is a subdomain, but still we need to validate both. So create the next entry now. Copying the value, creating the new record, add new record. Again, it's a CNAME record. Control V, and we need to remove the sourcesense.com.au. That is not required. And Control V again for the value and click OK. Again, half an hour TTL is fine. So we have created two records. So it is saying it has successfully created One other thing is that it'll take some time to bubble up the DNS records throughout the world. This is a public DNS entry we have created. So we need to wait some 5 to 10 minutes to propagate the entries we have made, and it'll reach to this Amazon servers when they does the DNS resolution. It's a very important thing to consider. Make sure that if you're doing this demo by yourself, you wait for some time, then only the validation will succeed. And you don't have to do anything on this page. It'll get automatically validated. And after some time, it worked. The entries we added worked, and the certificate has been issued. As you can see here, the not before and not after all has come up. So these are the certificate which is issued, and it has all kind of details here, other entries and things like that. So we got the ARN right here. This is the ARN we'll be using to use this certificate with these different services. Like I mentioned before, public certificates in Amazon cannot be exported. The private key, the certificate can be exported. The certificate can be exported, but not the private key. Basically, I wanted to show you the verification mechanism when a public CA will issue a certificate. Now, let's have a quick look at the private CA. We won't be creating a private CA. So this is the AWS Private Certificate Authority. We won't be able to see so much things here because we don't have a private CA created. You can create a private CA by clicking on this particular button. So you can create a root CA or sub CA, subordinate CA. Subordinate CA is signed by a root CA, which issues certificate. You can have any level of CAs in the chain. Again, exactly same as pretty much what we have seen while we were creating the certificate, all the details. Pretty much it is somewhere running an OpenSSL command behind the scenes. And this is one of the important statement to read if you're creating. This is the pricing information. So there are some free available, but in my case, I have used all the free available quota. By this time, all we are expecting is you should be able to understand what all these things are. Should not be any unknowns to you. So this is one of the things, CA permission options, authorize ACM permission to renew private subscriber. So which means that we are letting ACM to access this particular CA. So we are giving permission to ACM to operate with this particular CA, to issue certificate and export certificate and things like that. Mostly when you create a private certificate authority, we use it using ACM as a front end, create and manage certificates. So there are different types of CAs in AWS, general purpose and short-lived. Short-lived ones are less expensive, but general purpose is more expensive, and just like the name says, it is long-lived. It's all AWS specific stuff, nothing to do with anything we have discussed, all AWS pricing and stuff. Before we wind up our discussion on certificate, two things I would like to discuss is code signing and document signing. You should have no difficulty understanding these two things by now if you have followed the previous lessons. So code signing is signing a piece of code. So the idea here is code determines what is being done by a program. So you have a script here which does something, and you got it from company A. So this script is developed by company A, and you trust that company. This particular company generated this code. It's an application, say, for example, like Uber or Instagram or Facebook, some application which is known to you. At the end of the day, all the applications are piece of code, binary as well as non-binary code, which is executed in CPU, which will run on a device. So this particular code you're purchasing or downloading from an app store or something like that. Now, this is your device, your laptop, your phone, your server, where you have a lot of private information. Your private data is sitting here. And you're going to run this particular code inside the server right here. Now you need to make sure that this code right here is indeed created by this guy and no one else. That is where the code signing comes into the picture. So someone, again, similar trust chain verification will happen. Someone will create a thumbprint or a checksum of this particular document, binary file, the code, and create a signature, digital signature, and attach to this particular file right here. And once you get this thing right here, and you will know that it is created by company A by using your trusted CAs. Just like you are verifying a certificate, you are verifying code. Just that in this case, instead of certificate, it is the code, the actual code. That is called code signing. Very important. In fact, sometimes it's more important than the certificate itself because it verifies the integrity of the code you are running within your private network. It's very important. If someone has tampered this code and injected some kind of malware, the signature verification will fail and the code won't get loaded by the operating system. This is very important when it comes to drivers and kernel level softwares. And this is implemented in Windows. You cannot load a driver in Windows, system software in Windows, which is not signed by a trusted party. And this is very important when it comes to low level programs which can change anything in the system. For example, some of the drivers in Windows has to be WHQL signed or signed by Microsoft. Otherwise, they won't load into the operating system. So what happens is the third party software development company will write the software. Then they give that software to Microsoft. The Microsoft verifies it. There is a verification process. And then if the verification is succeeded and they are happy with what the driver is doing, they will sign it. And then you can load it into the kernel of the operating system. So code signing is a very important concept. Nothing new for us. Just that instead of the certificate, we use code. Let's have a quick look at some examples of signed code in Windows. So this is my C Windows system directory. And let's see some Microsoft signed executable. For example, this one, regedit.exe. I'm pretty sure this is signed by Microsoft. Let's see properties. Looks like this is not signed for some reason. I was expecting this to be signed. Let's see another DLL. Looks like this has digital signature. So this binary is signed. It is shown here. So the digital signature will be shown here. So it is signed by Python Software Foundation. Details you can see here. It is looking exactly like what we have seen so far. View certificate, we can see even the certificate. And it is having the full trust chain right here. So some of the binaries are not signed, some are signed. Signed ones are trusted by the operating system. I'm pretty sure operating system has a different way of trusting these kind of binaries because these are coming with the operating system itself. All it needs is to keep the checksum somewhere. Not a big deal. Let's go to the drivers folder. So drivers are in system32. Let's see some of these drivers, the signature of these drivers. So I'm just taking random drivers and it has a lot of signatures out here. So you can have more than one checksum. So that's another thing. For example, SourceLens had two certificates we have generated. One is from Amazon, which we just generated, and the one it has already being delivered. Like that, you can have any number of checksum. Looks like this has so many different certificate. So this is the Microsoft Windows hardware compatibility, which means that a third-party driver like this should have something like this. Then only the kernel will load this kind of drivers. So code signing is a very important security artifact when it comes to the integrity of the application you're running. How do we make sure that we are running Instagram or we are running Facebook or any other application? So that is where the code signing comes into the picture. Just like loading a web page, code signing makes sure that the code is intact and no one has tampered with the code. It's kind of more important than the SSL TLS thingy. I'm not undermining SSL TLS, but if code signing, if someone tampers with your binary, you can be easily compromised. In fact, it gets into the borderline of the second pillar of security. We have not discussed that, the bits and kernel level privileges, which is the next part of this training is going to cover. But the code signing is kind of overlapping with that particular pillar, which can be more lethal in terms of security breach, privilege escalation, and things like that. So in Windows, there is this API which verifies this code signing. The API's name is WinVerified Trust. So WinVerified Trust is the API, Windows API, which validates the signature of a binary. Pretty reasonably low level API, but it validates the certificate chain and things like that. It's not very important to us, but I'm just putting it out there so that you will hear this name somewhere and you will be able to connect the dots of what we are discussing. This is a program, C program, which verifies the trust of a binary. If you want to look into the code, you can have a look, and it gives the output, whether the application can be trusted or not. As you can see here, a lot of certificate related programs are here. If you want to review the code, if you want to get into the real details, these are the place to go. Also, you can optionally review the code of OpenSSL. OpenSSL is open source, of course. If you want to get into the algorithmic details and things like that, if you want to get into more core details. So that is code signing. And next is document signing. Mostly PDF has a signature feature. It is behaving exactly same as code signing, just that instead of code, it is a PDF document. Otherwise, it's exactly same. The principle remains the same. You have a checksum which is signed by SCA, and you can verify it that no one has modified the PDF document. So the code signing of document, or the document sign itself, behaves exactly like the traditional signature in a document. Although the digital signature has much more wider application, which we will see shortly, SAML and things like that. But at the end of the day, document sign looks exactly same as the traditional signature, the normal signature with a pen and a seal in a traditional document. You will get to know that it is signed by a non-person and it is to be trusted, and no one has tampered that document or no one has faked a document. So a lot of universities are giving their transcripts and things like that in signed format. So everyone knows that no one has tampered it. The marks has not been modified. So we have seen AWS ACM and certificate management in general. Also, we have discussed about AWS private CA. Maintaining a private CA is not a simple job. In organization before Amazon and cloud services, they used to maintain hardware HSMs, hardware security modules, to keep the key of the private CA. So we have discussed about the Amazon private CA, and we have touched upon digital signatures on code. We'll see that again in the second pillar when we discussed in the second chapter. That's all about it now, and I'll see you in the next lesson.